Welcome to SS2 Computer Science, Term 3, Week 8. SQL, Structured Query Language, is the standard language for interacting with relational databases. In earlier lessons, you learned basic SQL commands. Today we go deeper into advanced queries, join operations that combine data from multiple tables, group by for aggregating data, and aggregate functions. These are skills that database developers, data analysts, and software engineers use every day. By the end of this lesson, you will write join queries to combine data from multiple tables, use group by with aggregate functions, filter grouped results with having, and apply these skills to real-world database scenarios and WAEC questions. Let us begin. Quick review of basic SQL. Select column 1, column 2 from table_name where condition order by column ASC/desk limit and data types, int, varchar, en, date, decimal, ps, boolean. Constraints, primary key, foreign key, not null, unique, default. Our example database for this lesson, a school database, students table, student ID, pk, student name, age, class ID. Classes table, class ID, pk, class name, teacher name. Subjects table, subject ID, pk, subject name, teacher ID. Enrollments table, enrollment ID, pk, student ID, fk students, subject ID, fk subjects, grade. Teachers table, teacher ID, pk, teacher name, email. Why do we need join? In a normalized database, data is split across multiple tables to avoid redundancy. To get a complete picture, e.g. a student's name and their grade in a subject, we need to combine data from multiple tables. Join is the SQL command that does this. Without join, if you want to find Chidi's grades, you need student ID from the students table, then look up enrollments table using the student ID. This is complex in application code. With join, a single SQL query can combine the data automatically. Types of join. Inner join, most common, returns only rows where there is a match in both tables. Rows with no match in either table are excluded. Inner join syntax. Select students.studentName, enrollments, grade from students. Inner join enrollments on students.studentID equals enrollments.studentID. The on clause specifies how the two tables are related, the join condition. Example result, student name grade, Chidia, Emeka B, Ngozia. Only students who have enrollments appear, students without enrollments are excluded. Left join, left outer join returns all rows from the left table, plus matching rows from the right table. If there is no match in the right table, the right table columns return null. Example, select students.studentName, enrollments, grade from students. Left join enrollments on students.studentID equals enrollments.studentID. Result includes student name grade, Chidia, Emeka B, either null, either has no enrollment record, still appears with no grade. Right join, opposite of left join, all rows from the right table, matching rows from left, less commonly used, can rewrite as left join by swapping tables. Full outer join, returns all rows from both tables, null where no match, not supported in all databases, not in MySQL by default, but available in PostgreSQL. Self-join, joining a table to itself, useful for hierarchical data, e.g. employee and their manager, both in the same employees table. Multi-table join, joining more than two tables. Select students.studentName, subjects.subjectName, enrollments, grade from students. Inner join enrollments on students.studentID equals enrollments.studentID. Inner join subjects on enrollments.subjectID equals subjects.subjectID. This connects all three tables to get student name, subject name, and grade in a single query. Aggregate functions perform calculations on a set of rows and return a single value. Count, count the number of rows. Sum, column total sum of numeric values. AVG, column average value. Max, column highest value. MIN, column lowest value. Basic aggregate examples, select count, from students, returns total number of students. Select AVG, grade, from enrollments where subject ID equals 3, average grade for subject 3. Select max, grade, from enrollments, highest grade across all enrollments. Group by groups rows that have the same value in specified columns. Aggregate functions are then applied to each group separately. Syntax: select column, aggregate underscore function, another underscore column, from table group by column. Example: find how many students are enrolled in each subject. Select subjects.subjectName, count, enrollments.studentID, as student count from subjects inner join enrollments on subjects.subjectID equals enrollments.subjectID group by subjects.subjectName. Result: subject name student count, mathematics 45, physics 38, chemistry 42. Example: average grade per subject. Select subjects.subjectName, AVG, enrollment, grade, as average grade from subjects inner join enrollments on subjects.subjectID equals enrollments.subjectID group by subjects.subjectName order by average grade desk. Important rule: any column in the select clause that is not part of an aggregate function must be in the group by clause. Having clause, where filters individual rows before grouping, having filters groups after grouping. Syntax: select subject name, AVG, grade, as average grade from subjects join enrollments. Group by subject name having AVG, grade, greater than 70, this returns only subjects where the average grade exceeds 70. You cannot use where to filter on aggregate values, you must use having for that. Complete practical examples. Find all students in the SS2 class with their subject grades. Select s.studentName, sub.subjectName, e.grade from students s join enrollments e on s.studentID equals e.studentID join subject sub on e.subjectID equals sub.subjectID join classes c on s.classID equals c.classID where c.className equals ss2 order by s.studentName, sub.subjectName. Count students per class. Select c.className, count, s.studentID, as number of students from classes C left join students S on c.classID equals s.classID group by c.className order by number of students desk. Find teachers with more than 3 subjects. Select t.teachername, count, sub.subjectID, as subject count from teachers T join subject sub on t.teacherID equals sub.teacherID group by t.teachername having count, sub.subjectID. 3. Difference between where and having. Where, filters individual rows before grouping. Select where grade greater than 50 group by. Having, filters groups after grouping. Select group by. Having AVG, grade, greater than 60. Order of clauses in SQL. Select from join where group by having order by limit. WAEC questions on SQL join and group by. Write a SQL query to join 2 name tables. Identify inner join versus left join. Explain what group by does. Write a query using count/avg/sum with group by. Explain the difference between where and having. Trace through a given SQL query and state what it returns. Key points. Join combines data from multiple related tables using a join condition on clause. Inner join, only rows with matches in both tables. Left join, all rows from left table, nulls for non-matching right table rows. Multi-table join, chain multiple joins for complex queries. Aggregate functions, count, sum, AVG, max, min, operate on groups of rows. Group by, groups rows with same value, apply aggregate functions to each group. Rule, non-aggregate select columns must be in group by. Having, filters groups after group by, like where but for groups. Where, filters individual rows before grouping. SQL query order, select from join where group by having order by limit. Example, count students per subject, join students plus enrollments plus subjects, group by subject name, count, student ID. Example, find subjects where average grade greater than 70, group by subject name, having AVG, grade, greater than 70. WAEC, write join queries correctly with on clause, use group by with count/avg, apply having for aggregate filtering, distinguish where from having.